Pluto is a faraway, difficult to find, and less prominent planet that was once considered part of our solar system. Despite recent groundbreaking assertions from prominent astrophysicists like Neil deGrasse Tyson and Mayoaku, Pluto is back in the public eye. They have proposed that this icy planet might be heading toward a potential collision course with Neptune. But how can such a scenario occur, and what would it entail? Is it of such monumental proportions? Are we witnessing an unusual, unpredictable phenomenon, or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once classified as a planet but later redefined as a dwarf planet, continues to be a subject of fascination and study in the vast universe. Recent speculations from leading experts have suggested that Pluto's orbit is alarmingly close to Neptune's, prompting astrophysicists Neil deGrasse Tyson and Mayoaku to warn of the possibility of a catastrophic encounter between these two celestial bodies, which could pose a significant risk to Earth. But how could such a collision even occur? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes an incredible 248 years to complete one full orbit. And since its discovery in 1930, Pluto hasn't even finished a single full revolution. However, Pluto's orbit is not the end of the intrigue. It is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is the tilt of its orbit, inclined at an angle of 17 to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of the other planets, complicating its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is the way it intersects with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying the conventional expectation of their relative positions in the solar system. Naturally, this raises the question, why have Pluto and Neptune not collided? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Unlike the other planets whose orbits are relatively close to the solar plane, Pluto's orbit stands out because of its steep inclination and highly irregular shape. The puzzle deepened when it became evident that Pluto's orbit crosses Neptune's. Despite this, Pluto's orbit remains stable. Demonstrating the intricate dynamics of celestial mechanics, the so-called three-body problem in space. Understanding how three objects like Pluto, Neptune, and the Sun interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started, and how they influence one another. The stability of all planetary orbits is ensured by the notion of libration. That is, in the case of Pluto and Neptune. This means that whenever Pluto crosses Neptune's orbit, the two bodies are always positioned at least 90 apart. This spatial separation prevents a collision between them. Another contributing factor is the term orbital precession, which is the slow vertical movement of a planet's orbit. For Pluto, this means that when it comes closest to Neptune or any giant planet, it is positioned well above their orbital plane, providing another layer of defense against potential collisions. An additional factor at play is the VSSK wobbling, a concept named after three researchers, Zell and Kai, who studied how celestial bodies interact with one another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable for a long time. The gravitational pull of Pluto, Neptune, and the Sun influences Pluto's orbit, ensuring it remains relatively smooth despite its irregular shape. The VSSK wobbling shows that even in the most unpredictable environments, there are underlying patterns and forces that maintain stability. This three-body problem-solving is essential for understanding the nature of Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. Numerical simulations conducted in the late 1980s revealed that Pluto's orbit, despite the actual stabilizing forces in play, is quite erratic. Small deviations in its initial conditions could lead to significant variations in its route over centuries. These simulations also showed that Pluto's orbit maintained stability over incredibly long timescales, such as millions or even billions of years. To fully comprehend the dynamics between Pluto and Neptune, it is important to consider the gravitational influence of the giant outer planets like Neptune, Jupiter, and Saturn. Neptune's influence is significant, as it governs Pluto's orbit in a special resonance. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This gravitational resonance helps keep Pluto's orbit stable. But Neptune is not the only player in this complex equation. Jupiter's massive gravity also plays a key role in stabilizing Pluto's path, while Saturn further contributes to this dynamic. These forces, working together, ensure that Pluto remains on a steady course for potentially millions of years, keeping it out of harm's way from the influence of Neptune. Without these stabilizing forces, the solar system would be much more chaotic, with planets potentially colliding or being ejected from their orbits, causing catastrophic consequences across the solar system. The possibility of Pluto colliding with Neptune in the future highlights the complexity of celestial mechanics and the importance of studying the stability of orbits. By understanding these intricate dynamics, we gain a better understanding of how the solar system works, the role of gravitational forces, and the actions of faraway objects. Even though Pluto's orbit may appear chaotic at first glance, it is a testament to the delicate balance of forces that keep it in place. Exploring space often leads to surprising discoveries, and Pluto's irregular orbit serves as an excellent illustration of the mysteries of the cosmos. The concept of orbital chaos illustrates how a celestial body's orbit can be highly sensitive to its starting position. In Pluto's case, even small changes in its position or speed could drastically alter its long-term orbit. Automated simulations have proven invaluable in helping scientists study these behaviors. By modeling how Pluto and other objects like Neptune influence each other through their gravitational pull, these simulations show how even the tiniest adjustments in conditions can have a significant impact on Pluto's trajectory. Though Pluto's orbit is stabilized by mechanisms like libration and precession, simulations have also shown that Pluto's orbit is not very stable. Slight variations from its initial conditions can lead to vastly different outcomes, making long-term predictions about its movement extremely challenging. Despite this apparent chaos, Pluto's orbit remains relatively stable over geological timescales, like billions of years, suggesting that, even in the midst of seeming chaos, there is an underlying order to Pluto's motion around the Sun. Predicting celestial movements, particularly for objects with irregular orbits like Pluto, is a massive challenge. The inherent unpredictability of these systems signify that any long-term forecast is filled with uncertainty. Numerical models help us understand and anticipate these movements, but their accuracy depends heavily on precise initial conditions. Even a slight error can produce drastically different outcomes, making it challenging to forecast Pluto's future trajectory with confidence. Aside from the chaotic nature of planetary orbits, the story of Pluto serves as a reminder of the dynamic and ever-changing nature of the universe. Despite the many advancements in our knowledge of space, Pluto's case demonstrates how much we still have to learn, grasping the giant's gravitational influence. The planets that orbit Pluto provide us important insights into the broader mechanics of the solar system, showing how the position of each planet can significantly affect the course and stability of others. So, why do they stand out? Astronomers express concerns regarding a possible collision between Pluto and Neptune. Despite all these stabilizing factors at play, Neil deGrasse Tyson, one of the leading astrophysicists and individuals accountable for Pluto's reclassification from a planet to a dwarf planet, offers an insightful perspective on the ongoing mysteries of our solar system, including Pluto's. Tyson has contributed significantly to shaping the public's perception of Pluto and to understanding its place within the evolving landscape of our solar system. Tyson views the reclassification not as a loss but as an essential adjustment based on our expanding knowledge of space. Tyson's approach to celestial bodies, celestial mechanics, is one of constant discovery. He sees the discovery and evolution of orbital complexities like Pluto's as indicative of how much more there is to learn about the universe. Although Tyson remains optimistic about the study of Pluto, his views regarding the potential of a collision with Neptune suggest that numerous questions remain unanswered. Will Pluto collide with Neptune, or is this merely a momentary confusion in the ever-evolving cosmic system? Only additional time and study will provide the answers. At this time, we are left with an even greater curiosity about how much is still unknown about our own solar system. The possibility of a Pluto-Neptune collision invites further examination of the mysteries of the universe, and it challenges our comprehension of the dynamics of the planets. The prospect of two celestial bodies with a collision of vastly different properties raises intriguing questions about how the solar system is shaped by gravitational interactions. The development of the solar system, a collision between Pluto and Neptune, would not only have major implications for our comprehension of planetary behavior, but would also provide valuable insights into the solar system's evolution itself. To understand the dynamics of a possible collision between Pluto and Neptune, you must take into account the characteristics of both planets. Pluto, though classified as a dwarf planet, contains a variety of elements and compounds that have frozen due to the extreme cold of the outer solar system. Its surface is covered with nitrogen ice, and its atmosphere is primarily composed of methane, nitrogen, and carbon monoxide. In contrast, Neptune, a massive gas giant, consists mainly of hydrogen, helium, and other lighter elements, with a deep, dense atmosphere. A collision between these two vastly different bodies would, no doubt, have profound effects on both planets, conceivably triggering an event that could be seen from vast cosmic distances. However, it's important to note that Neptune's gravity is not the only stabilizing force at play. Jupiter, the largest planet in the solar system, also exerts a significant gravitational pull, contributing to the stable orbit of Pluto and preventing it from venturing too close to Saturn's domain, or Neptune's gravitational influence. This further complicates the interactions in the outer solar system, making it unlikely that a devastating collision between Pluto and Neptune will occur. While Neptune's gravitational influence plays a significant part in maintaining Pluto's orbit, the complex relationships between other planets, such as Jupiter and Saturn, further ensure that Pluto's path remains steady. However, research has also shown that the relationship between Pluto and Neptune is not as straightforward as a potential collision course. The gravitational resonance between the two planets, in which Pluto completes 2 orbits for every 3 Neptune accomplishes, creates an inherent barrier that hinders them from colliding. This resonance, often described as a gravitational dance, ensures that the orbits of Pluto and Neptune, while intersecting, never result in a collision. This mechanism is an extraordinary illustration of how celestial bodies maintain a harmonious relationship despite the tumultuous forces at play in space yet. The future of this delicate balance is not guaranteed. Small shifts in the positions or velocities of these planets could disrupt this resonance and lead to unpredictable consequences. These shifts could be triggered by external forces, like the gravitational influence of an unknown planet or a fleeting star, or by internal events, such as tidal forces causing gradual changes in the orbits of these bodies. Studies and observations of Pluto, Neptune, and the surrounding bodies in the outer solar system are necessary for comprehending the long-term stability of their interactions. As new technologies emerge, researchers will be able to improve models and gain a clearer understanding of the interactions between these far-off objects. Brand new data may illuminate the delicate equilibrium that holds Pluto and Neptune from colliding, or it may uncover entirely new forces that could alter their relationship in the future. As we continue to study the dynamics of Pluto and Neptune, one key factor that has emerged is the possibility of an undiscovered object influencing their orbits. This hypothetical object, often referred to as Planet 9, is believed to exist in the far reaches of the solar system. Some scientists have speculated that it could alter the orbits of objects like Pluto with its gravitational pull, possibly leading them to try new paths that could shake up their current positions. While the existence of Planet 9 is still a subject of debate, its potential impact adds another layer of complexity to the situation. In addition to the gravitational interactions, that occur between planets, it is important to consider the broader context of how the solar system itself is evolving. The Sun, the dominant gravitational force in the system, is gradually losing mass through the process of solar wind. As the Sun loses mass, the orbits of all the planets, including Neptune and Pluto, could gradually expand over time. This process could shift their relative positions and affect the long-term stability of their orbital resonance. Furthermore, the outer solar system is not a static place. Objects like comets and other small bodies are constantly passing through, exerting their own gravitational forces. These passing objects could occasionally disrupt the orbits of distant planets, including Pluto, even though such occurrences may be rare and unpredictable. The combined effect of these varying forces may ensure that Pluto's orbit remains dynamic, constantly adjusting in response to the resulting gravitational dance between the planets.